Okay, good morning, everybody. Hello and welcome to the Efficient IP webinar on how to combat DNS data exfiltration. I really hope everybody is doing well this morning. My name is Gary Bootland. My role here at Efficient IP is the EMEA North Channel Manager. Before we get into the webinar, I just want to go over a few housekeeping items, if that's okay. So if you're joining us live, you'll receive a follow-up email with a link to the replay recording of this session. We hope that you will be able to share this with your peers, your colleagues that were wishing to join but unable to, and obviously they can then review that link and watch the webcast at their own convenience. Also attached within the same email will be a download link to the slides that you'll be reviewing today with myself and Nick. And finally, if you wish to ask us any questions during the session today, do please feel free to use the questions chat box in the bottom right-hand corner of the GoToWebinar control panel. We'll answer those questions at the end of the presentation. So, today you'll be joined, as I said, by myself, Gary Bootland. I've been at Efficient IP for probably about 15 months now, roughly. So fairly maybe new to the business and the DDI market, but I've got a fair amount of experience behind me, despite the young looks. 20 years in the network industry, as you can see. And my esteemed colleague Nick Fennell, one of our senior pre-sales engineers, also. He's been within the organisation here for a good number of years, but has a lot of industry experience, as you can see, 10 years within the DDI market. So there's not a lot Nick doesn't know within regards to DDI. Cheers, Nick, if you can push the slides on to the agenda. Perfect. So as I said, we're going to be focusing on these key points, questions at the end, some key takeaways to kind of like wrap things up, along with some demo videos that Nick will talk us all through. And finally, a Q&A at the end. So the next slide, who are we? Who is Efficient IP? So we're a network security automation company. Our core focus is around DNS, DHCP, and IP address management, or IPAM, or AKA DDI. DDI, DNS, DHCP, IPAM, these are the key foundations of an IP-based infrastructure. Our mission and goal is to help all organizations deliver dynamic and secure communications between the apps and the users. So, protect the DNS on the network, in order to safeguard against any data theft, protects the users against malware, and ensures service continuity. We use open APIs, thus allowing us to send actionable data to the security ecosystem, such as SIEMs, SOCs, or security policy managers. And finally, as you can see, there are 1,000+ customers in all industries scattered across the world, shaping in different sizes, different verticals, etc. We have global presence because of this. So we have offices in Philadelphia, EMEA, Paris, covering Germany, Spain, the United Kingdom, and then we have offices in the Asia Pacific region. So this slide really does, as I said, highlight a number of our global customers that we support. They're ranging in size and industry, as stated before, but all with one common goal, which is to protect the apps and the users. We support many a project here with regards to data transformation, SD-WAN. It's never just a one and done here. These are relationships that we've forged over many years now, which allow us to keep the lights on with a lot of these organizations. That would be it from myself at this time. I'll speak to you all again at the end during the questions. If you do have any, please do send them over. But now I will hand you over to my colleague Nick Fennell. Cheers, Nick. Thank you very much.
Cheers, Gary. Thanks for that intro. So yeah, welcome everybody today to the session. The topic, as Gary mentioned, is going to be on DNS security, sort of loosely or predominantly, and then DNS exfiltration. So before we sort of kick off into the subject matter, there's just a little field work to do, I guess. We'll look at the landscape. So DNS security landscape as a whole, or as an insight into, is predominantly affected by malware. 91% of malware is using DNS service. So in the scheme of what businesses are facing, of which 82% of businesses are facing, the majority of attacks using malware are using DNS to coordinate around the business. Now the attacks predominant and wide-reaching are causing an increasing amount of disruption, not just to the technical aspects of the network, but to maybe the financial, the revenue-based aspects. 1 of 8 organizations suffers data theft by DNS directly. So this will be by exfiltration, typically, people using low-level type attacks to steal the secrets of the business out by the protocol that's potentially not being watched. And this is all happening because legacy security solutions are not adapted for DNS, and as we say, the hackers know it. There's 3 reasons why DNS is being ticked. And I mean being ticked as a target for attack or for vectoring, which we'll get into. And the first reason is that DNS is critical for business service. The majority of applications are using DNS to route or to make decisions in how their traffic is being routed or handled or targeting. It's the service that is connecting the users and the applications together in the first instance. So it's vital for a productive functional network to operate. Without DNS, things are not as flexible. DNS is easy to exploit. It's open by design and always has been. Its entire premise is to be a directory of information that anybody can come and query for near enough any reason. It wasn't particularly designed with gating or lockdown at the forefront. It was about getting answers to users. As I mentioned previously in just the prior slide, DNS is not effectively protected by standard security solutions. And we'll get into this topic. It's not protected particularly well by next gens, by proxies, or by sort of like packet scanning, packet detection. So attackers are using the DNS service as a twofold weapon, if you like. They can use it as an attack target, or they can use it as a vector. They're making use of the dual role in the kill chain, because why just attack something if you can use it to attack something else and maybe obfuscate what you're doing? Attacks manifest in a number of different ways. We see them in in-house app downtime, and apps could be like email, telephony, CRM, web access generally, or something more precise. It could be that your website is compromised, or you lose access to your cloud. It could be that loss of business and brand damage occur because you're not online. Customers are trying to get to your website at the peak of interest and you're not available. Or it could be that information has been stolen by the protocol, or via the protocol, I should say. Now, it's important to mention that DNS impacts businesses, or can impact businesses in a number of different ways. It's not always, clear cut like a DNS outage. And as the topic of the talk today would suggest, that one of the methods that we see, witness, and hear of is exfiltration via the DNS protocol. And we're often asked, how does that work? Conveniently, I have a slide that matches that exactly, and I have more slides that can take us through. So first of all, the DNS function relies on 3 different functional aspects. It revolves around an authoritative arm, an authoritative resolver, a cache function, and a recursive engine. So the 3 functions are typically part of one instance, and in this instance, a user is asking for efficientip.com. Their query is forwarded to their local cache resolver, and if the query is in the cache, it's returned to the user immediately. So great for performance, and no forwarding of traffic out to the internet. However, if the query is not within the cache, we then see the traffic flow reach much further than just our local instance, and we're actually out to the internet, and we're out to a server maybe and potentially far away. So this query has basically been routed through our network to the internet, to a third-party resolver or a third-party server, let's just say, and then its response has been pushed back into our network. So here we say the answer is not in the cache. The cache relays it to the recursive. Recursive gets it from the authoritative. The answer is communicated and stored in cache memory. So that's typical for how a DNS flow would work in most, and if not all cases. Now, the DNS attackers know this, and they use this to their advantage. So they can use this for infecting of devices, and then controlling malware by backdoors, command and control. They can use this method for exfiltration, which is what we'll be looking at. Or we can be using it for remote control. So infection and remote control can be two completely separate entities. But the commonality in all is that it's done by DNS. So why doesn't say like next gen firewall cover us from these types of things? Well, typically it's because all the traffic is normal DNS. It's not, as we say here, it's not abnormal in the sense that it looks strange to the resolver. It's abnormal by our definition because that's not what we expect. But it's not abnormal to the DNS function or to the next gen firewalls that are potentially guarding these services. So the hacker's doing the same thing as what our innocent guy was doing before. He's sending his query, but in this instance, he's looking up confidential-data-accomplice.domain.com rather than just www.eip.com. Same thing though, the query is pushed out through the cache engine. It's not there, it's pushed out to the recursive layer. It comes out to, this time, the attacker's third-party server. Because the query is going to its domain is not known by RPZ, or there's no signatures because he's only just created it, or she's only just created it for equality purposes. The domain isn't tagged anywhere, so the query gets sent through. So if this data was more than just a query, innocent query, well, this means that anybody can push anything out of a DNS server at any point. And that is precisely what we can do and demonstrate. And this is something that I've been talking about for many years now at many talks. But a scenario exists where an insider on the network wants to send data outside of the network. We stipulate that it's secure, firewalled, obviously most are, but the requirement is pushing from inside to outside. It needs to be undetected, so they'll do this by hiding traffic amongst DNS traffic. Hiding their activity amongst the DNS traffic, because that traffic's able to pass through to the secure public internet without restriction. The method needs to be simple. It can't be anything complex or that requires installation or like unpackaging or deployment or something like that. So what I will do is I'll explain the technique that we use here, and we've got an example of basically how we do this here. So we're going to show that now. We've got a couple of captured videos to make sure that it works the same way every time. But the attack we'll be using is using a HTML feature called DNS prefetch. We'll be able to see data being sent from the source, the client, the initiation or the origin point, and then we'll be able to see data arriving at the remote endpoint as well. So I have a video, so I'm just going to click to start this now, and we'll see this rolling. And it just highlights basically that the enhancement, the DNS prefetch part, is a design feature. And it's a design feature because what it'll do is it'll fetch the URL IP that you're connecting to before you actually click the link yourself. So it's like an optimization. If you imagine you've got something like eBay, there's hundreds of links on a single eBay page that you scroll down, and every time you scroll, your browser is prefetching those URLs. Now we can use this method, and we use that practice to push data through the network, basically. So we have a file of data that we want to push out. In this case, it's a dummy data, has some usernames and some digits in, but We encode it into base64 using a simple command. We get an encoded string. And then we take our encapsulated string, we take that and we then split that down into a series of records or a series of queries. So you can see the encoded is the same as the characters. And these are all now formatted in the form of a DNS lookup. So we've carved that query, that long string, up into about 12 different queries, 13 different queries. What happens then is that we can forward these out by the DNS protocol. So if we're watching on our router at the top, and if we are monitoring our DNS server at the bottom, what we'll be able to see is that when the origin point begins to communicate the DNS records that it's now built, we'll see that through the router, these things are sent. Now, what we're able to do is put this, as you saw, the extract of the code at the start was from a simple HTML script. So this is the page. It's as simple as this. It's only like 50 lines at the back end. Gives you an ability to click a text file and to upload it. And when you've clicked the text file, you'll see that the page is breaking down the content into a series of DNS queries. And you might be able to notice these, they're scrolling past a little bit, but they're all a series of characters like a string.pentest.hack53.shop. The important part to notice is that the top end and the bottom end are moving at the same rate. So this is confirming transmission and it's confirming receipt, because we could see it going through the router and we could see it arriving at the target, at the end point. Now we just wait for the traffic to clear up. And then we can check using a script that we have on our accomplice server, the packets we've got, if we can decap or decode them into something discernible. And you can see there that we actually have the contents of that text file. Now you'll have to trust me that we didn't just open up a random text file there. The contents you see in that bottom window is genuinely what was communicated via the text file in the web page that we showed in the video. Sorry, I clicked the wrong way. So this is a real thing. So this is that's a simple HTML page that's using the standard DNS protocol without any modification, change, special consideration, and we can then use it as a proxy server almost anywhere. So how can we do something about this? Well, there's 4 steps. You need to collect the relevant data. You need to analyze the data in real time. You need to implement countermeasures, ideally adaptive, to keep business continuity flowing, and then share information to the security teams and to the management teams, so that if there is something going on, we can take ownership of it and sort it. So step 1 for efficient IP, collecting relevant data with complete DNS transaction inspection. This is unique to efficient IP. And it gives us the ability to understand what's going on in DNS from end to end. We don't just want to see the queries going through, we want in-depth visibility, back and forward, because we want to be able to detect whether or not we have abuse or misuse going on. So if we want to be looking for malformed requests or recursion time abusers or bandwidth consumption, soaking or exfiltration or tunneling, we can see that because we're looking end to end. Now, if we're looking, we want to be able to perform advanced real-time analytics so that we can enforce the end-to-end security. So we want security from the source to the destination. That's vital. We want to go between these 2 parts, well, circle between those. We don't want to have a break in the middle. So we analyze the behavior of the client and detect attacks there. We look for the malicious domains that we might be going to. So using intelligence, things like Serval, RPZ. If we know something is bad, we don't necessarily need to communicate to it at all. But if we're looking in the middle and we're looking at both ends, then we can potentially see quite quickly, you know, what's happening for exfiltration if there's things like tunneling or zero-day attacks occurring. So, you know, the benefit of that real time is that you can make decisions in real time, and that's where adaptive countermeasures come in, as opposed to just deploy and forget type protections. Adaptive countermeasures allow you to use the information you have to influence the control you're making or taking. So our engine is split into a few different ways of guarding the traffic. We have our quarantine part of the resolver. We have a rescue mode, we have a block mode, and we have a normal mode. So block is just a simple block, just drops all traffic. Rate limiting can be applied to normal traffic if it needs to be slowed down, regulated, held back. Quarantine keeps people stuck to the cache, so no recursion. And then rescue mode is a whole suite of features aimed at ensuring business continuity and protecting you against false positives, because we know that false positives within this arena, should I say, are notoriously difficult to sidestep and avoid, especially with traditional methodologies. So with our first 3 steps, we now want to integrate into the ecosystem. We want to be able to automate and orchestrate. We want to get out of the security silo scenario, and we want to get end-to-end. We want to be able to share this information around the ecosystem because it's contextual, it's relating to us. You know, it has as we say, actionable threat intelligence. So actionable threat intelligence is stuff that's pertinent to us. This is information that's really based on our network and you know is important to what we're trying to do. So this approach allows us to improve detection, fix things faster, stop things from spreading, so like malware. Extend the security perimeter into DNS is a good thing to do to begin with, and then enforce the policies on our users that we want. So if we don't want users going to certain parts of the internet or to certain parts of the network, then we can stop and you know, check that that's taking place and users aren't going where they shouldn't be, or that they're not doing what they shouldn't be doing, because that's the most important thing. So let's have a look at the demo again, or the examples again, but this time with a method to protect the network or the user. So much the same as before, you know, we're going to select the data, we're going to exfiltrate it, we're going to watch it being sent. This time we're going to observe the data not being able to arrive at the endpoint. And then we'll see a quick walkthrough of the Guardian events that pop up to confirm that the traffic has been blocked. So another captcha. If it will work. Sorry guys, I appear to be having a technical difficulty. This is typical. I have a video here that's supposed to be playing, guys, but it's definitely not for some reason or another. Give me 1 second. Oh no, I tell a lie, it is working. It's just that I couldn't see it moving. So let me just repeat that slide. So we've got the same thing going. Packet capture at the local router, queries being captured at the DNS server. So it's the same as before. However, this time when we do our exfiltration, we're using the same file, the same everything. We see a difference in behavior. I mean, there's nothing received by the target, for one thing. That's the first noticeable thing to me. But as we just conveniently confirm, only 6 packets were sent, or 6 packets were noticed by the router, forwarded by the router to that target server at the bottom. Now that's because we have the traffic going through our DNS Guardian. Now DNS Guardian is our security solution. It's detecting the activity, and based on a predefined trigger that we have that's looking for things like, say, DNS exfiltration, we're able to not only detect the behavior, but then trigger activity to take action if that type of behavior is noticed. So we see on our platform here, we're observing that the trigger has been armed, and we can see that we've got a trigger armed there for DNS tunnel, and that tells us that the protection has been activated for a particular client. Now, DNS Guardian's got a lot of analytics in it, so more than just picking up the bad guys, you can keep an eye on what's going on, you know, in the legitimate sense as well. So I was mentioning earlier abuse and misuse. So it's not all about you know, hackers and you know, disruptors. There are general cases where just general usage can be disruptive, but in the most common cases, you know, it's the bad guys or the bad actors we want to get first. So we catch it in our interface, and then we, you know, as part of the ecosystem, can export events across to the tool. So this is Kibana that we're showing here, and we can see that the trigger information has been communicated to the Kibana platform. So it's just an open example of one of the technologies that we use, not limited or restricted to Kibana in any way. But the point is that the information doesn't stay siloed. We mentioned silos. If we detect something, if we see something, if we observe something, we want to communicate that information around the network. We don't want it to stay, you know, within our platform, because that doesn't help the rest of the network to harden up or to protect. If you remember at the very start, we said that 91% of malware abuses the DNS to abuse the network. It's just there. It's an underlying protocol or transport that exists in every network. I mean, of course, there'll be exceptions where there are no DNS at all, but in the majority of everyday networks, we're all using DNS. And we're all, inverted commas, subject to this type of abuse or this misuse taking place. Now, because DNS sees basically everything that's going through it, it's a very, very valuable source of information or intelligence to learn from. So it's the one aspect of the network that is touched by near enough everything. Most devices, mobile these days, will use DNS to even figure out if they're connected to the internet. So before you see other sessions appearing, HTTP or otherwise, an iPhone, for example, will go to connect to Apple or whatever it is, or a SkyQ box goes to connect.sky.com. You know, there's DNS is at the start of the chain. So if we can get information there about what clients are behaving, or how they're behaving, sorry, what they're up to, we can bring in the intelligence, or we can create our own intelligence. If we're observing our own clients, then we become aware ourselves. So we tighten up the entire premise, you know, the landscape. The security posture becomes a bit tougher, a bit firmer, a bit straighter, and yeah, business continuity and functionality and productivity is maintained. And Efficient IP do this with our 360-degree security approach. So this is an approach not to detail every section, but that feeds round literally 360. So each aspect feeds into the next, and then the benefit is almost like reciprocal in the sense that yeah, the benefit from one echoes into the next benefit. So at the end of that, we are into the questions section. So I will open up my chat panel and have a look at what we have.
We do have a question.
We do, right?
We have a number of questions.
Oh, brilliant. That's what we like to see.
We've just had one just come in there and then, so we'll grab that one at the top. So question from the room is Guardian also supported with DOT and DOH?
Ah, right. Okay. Yeah. So DNS over TLS, DNS over HTTP. So these are projects that we're tracking, and we're actually releasing support for pretty much in the next couple of months. Our 7.2 release will introduce support for this. We're interested to. I'll be honest here. We're interested to talk with anybody interested in two of those, because it's an evolving practice, an evolving approach to use these technologies. So yeah, we're keen to discuss those requirements, because we see the benefits, but we understand it's a conflicting landscape around those two technologies for different reasons. But yes, DOT, DOH are supported in a version that's out in the next month or two.
Would you want to, Nick, would you want to catch up with the chap who asked the question offline in that case?
Always is the answer to that. Yeah, I mean, as I say, it's a very interesting topic around the industry for how these two technologies that will work. So from a business perspective and from personal, I'm interested to talk to anybody with a use case, so that we as a vendor can just stay on the edge of the requirement. We don't want to fall into that middleware lull where we're reacting. So yes is the answer to the question. We do and will. And yeah, I'd be happy to have a further conversation about that as well, if possible.
Got a couple other questions pitched for you, Nick. I think they're all aimed at yourself. How does your solution interface with SIEM products?
So very easily is my layman's response. So we have a number of different ways to push data out of the platform. We're very API centric is the first thing to focus on. So for interactions and integrations, the API we offer, which is REST, gives 99.5% functionality of the entire platform. So there's nothing you can do via API, for example. Nothing we do in our GUI that we design that you can't do with just the API, because the two things are the same for efficient IP. And what I mean by that is that if you wanted to build basically an equivalent interface to the one we designed using just our API, that's completely possible. It drives everything. So taking data feeds by syslog, by SNMP traps, or by API integrations, and using things like workflow, allow us to integrate into all manner, not just SIEM and SOC, but all manner of third-party software or service, using those sort of open approaches. We have a number of sort of standard integrations that exist as well. So if there's something that's in particular, let us know what it is that you're using or intending to use, and we can confirm, what capabilities we have or are possible, and we can always review that as a requirement.
We've there's this one. Bear with me, Nick. It's quite a long one. A few questions within a question. Where and how do you deploy this? Is the Guardian a dedicated hardware appliance, or could it be virtual? And does it require architecture to be redesigned, or can it be deployed as an additional layer? I think there's 3 questions in that.
That sounds like a question that I would ask somebody on a webinar. So the first question: how and where can it be deployed? Guardian is transparent in the sense that it can be deployed in front of an existing architecture. But I used the word transparent incorrectly there, because it does have to be part of the flow. So it's not like a stateless device at the moment. So you would deploy it by effectively sticking it in front of whatever DNS architecture you have right now. So if it's a Microsoft architecture you've got, or an efficient IP, or if it's ISC, or an alternative, it can be anything, you're able to deploy DNS Guardian in front of that, configure the network and its clients and devices to use the Guardian, and then simply use Guardian to push the queries to whatever architecture you are using. So in that instance, it becomes like a layer, security layer, protecting your existing infrastructure. Now you can do that on hardware and virtual. We support the both. And from architectures that are either existing or new, the configuration just depends really on what the intention is. So if it's an existing fully built architecture, as I say, that the Guardian can just be deployed in front of it, and it requires no change to the back end at all. As an example, if I was to turn up for a POC with the Guardian solution, I could arrive on your network, and given all security was satisfied, deploy the solution in front of the existing DNS and give all of the behavioral tracking activity protection, all of that, without, as I say, modifying anything on the actual business DNS platform itself. So yeah, it's very versatile. Just the last part of that question, Gary, did I hit that? I remember it was how can it be deployed? Where can it be deployed?
Yeah.
And how? Hardware last bit.
Yeah, sorry. So how to deploy? It can be hardware or virtual, yes. And then the last piece was, does it require architecture to be redesigned, or can it be deployed as an additional layer, as you say?
Oh, yeah, okay, yeah. So that's cool. Yeah, so yes, it can be deployed as an additional layer, and it's predominantly, well, it was predominantly recursive, but it now is available for authoritative service as well. So we focus on the recursive here, but the protections exist for authoritative servers. So if you're hosting authoritative servers on network and you're worried or scared about, say, protocol abuse, people sending exploits at bind, for example, you can put Guardian in front of your authoritative architecture and protect the servers from that direct abuse. You use this as a buffer, as I say, without having to change what's providing the actual service behind it.
And maybe one more question. Can it protect mobile devices? So BYOD, I guess, maybe, as well as.
Yeah, no, of course, yeah. I mean, it protects anything: fixed devices, mobile devices, transient. So if you've got laptops, so things that might be Ethernet or wired, really anything. And I should actually, let me change the question. It doesn't protect, I say, the mobile devices. It protects mobile devices against mobile devices, and it protects the network from the mobile devices. So the good way to think about this is that DNS security for DNS is twofold, really. You either have users trying to disrupt users, or you have users trying to disrupt the network. And if they're trying to disrupt the network, they're trying to disrupt the network for everybody. So DNS Guardian is doing two things. It's keeping the users secure so that you're not, say, harboring a malware infestation that's propagating around the network, because we're blocking those original queries, or we're detecting them and keeping them jailed out. Equally, if someone decides to hop onto the network and they're feeling a bit disruptive, they've got the latest version of Kali Linux loaded up, and they're firing the denial of service tools up against the Wi-Fi access points. Whatever it is, you could use DNS Guardian, or DNS Guardian can be on the network to protect the core against people on the edge. So we've seen in places where people are DNS tunneling live streaming, because you can get 1.5 meg throughput through a DNS server, do DNS exfiltration. So not a huge amount, but yeah, it's quite a bit. And that, if you've got that for a number of users, can really, it can destroy DNS services. So protecting the core network from what the users are up to is just as interesting and just as important to us as protecting the device itself. So yeah, mobile fixed devices, core, whether it be firewall, switches, routers, everything is configured to use the Guardian, and then the business really can see everything that's occurring in DNS, whether it be good or whether it be bad, or just misconfigurations. You'd be surprised how many reverse records don't exist anymore that should do, that actually cause DNS servers a lot of waste. So yes, very versatile.
Nick, we have a follow-up from Jan, who asked the first question in regards to DOT and DOH.
Oh yeah, okay.
Will Guardian work with these transport layers?
Yes, so what we would intend is that Guardian would be an endpoint, I guess. I mean, and this is why I say at the moment, the conversations are very interesting, because there is a lot of this thought going on into how this is going to work. Conversations around how you configure client devices, and how you keep. Because I tell you what, the conversation's interesting, because as many people are trying to block the activation of DOH, DOT, as they are trying to enable it. So for us, it's interesting because we're having to play it both ways. So we perceive that Guardian would be configurable as an endpoint, as a target, and potentially, I mean, I'm not sure how it would work in actual fact, and it's probably why the conversation is a good one to have offline. But in actual fact, we'll see this on all of our DNS as well. So it won't be limited to just DNS Guardian, but even our traditional DNS resolver, whether it be bind based or otherwise, we expect to see this implementation appearing. So what I would say, Jan, is that yeah, it's something that we're deploying, and we have deployed, and we'd be happy to talk with you about how it can work for you, just to make sure I'm giving the right advice on how and where it should be deployed, basically.
All right, we'll connect the two of you off the back of this one. Cool, cheers, Nick. Brilliant. It doesn't look like I've got any further questions, so we will go ahead and wrap things up there. I'll close out just by saying thanks again. Please do keep an eye out for the email with the link to this presentation and the slides. Probably come over in the following days. If you do have any more follow-up questions or comments, please do not hesitate to contact us. So we will wrap it up there. Thanks again for joining. Have a great rest of your day. Please do all stay home and stay safe. And again, thank you very much. Take care.
Thank you, everybody.
Cheers, Nick.